Okay, now we can use the setTransition method to define the transitions we want going from one scene to another. We're going to need to do it twice down here at the bottom of our method where we're defining our transitions. So first, mTransitionManager.setTransition, and the from scene is going to be from mExpanded. We want to go to mCollapsed, and we want to pass in the collapse transition set. Then we want to do basically the same thing, but in reverse. mTransitionManager.setTransition. This is from mCollapsed to mExpanded, and we will use the expand transition set. Now remember to call the enter method of the starting scene, which switches to the scene without any animation. Without this call, the following transition won't work properly, so don't forget about it. mCollapsedScene.enter. Now there's one more thing we need to do. In order to toggle the two scenes back and forth, we need to remember what the current scene is. So let's add another member variable to track that. So up here at the top, we'll add another one called private scene mCurrentScene. And we'll be able to track which scene it is using the enter action of both scenes. Remember to set the enter actions before calling enter for the first scene. So we've done that already because we copied and pasted it. So here in Setup Transitions, we have the enter action for mExpanded scene. And in here, we just want to add a line to set mCurrentScene equal to mExpanded scene. Now we can scroll down to our collapsed scene, and here's the enter action again. And we can do the opposite. mCurrentScene is now going to equal the mCollapsed scene. Don't forget that we still need to ask Butterknife to bind the views again here, otherwise the track panel will stop functioning after one transition. So finally, let's go to On Track Panel Clicked. In here, we want to ask the Transition Manager to transition to the target scene, which is determined by looking at the current scene. So here, maybe the code will make that make a little more sense. So if mCurrentScene is equal to mExpanded scene, then we want to update it to mCurrentScene equals mCollapsed scene. Otherwise, mCurrentScene should equal mExpanded scene. So this is the actual toggling, and now we can call mTransitionManager.transition to the new scene. So mCurrentScene now has the correct scene to transition to. Okay, so this should be everything we need to transition back and forth. Let's run it and see. Okay, so let's go into the first album. And if we transition to the lyrics, okay, just like before, and now, yay, we transition back. Cool, this is how it looks when we run all that code we just wrote. Scenes are building blocks of transitions, and it's important to have a good understanding of the concept. However, it's actually possible to use transitions without manually creating scenes. This is especially convenient when the states of your target scene are dynamic. If you call the method begin_delayed_transition, and then update the children views of transition root, the framework will automatically create a scene based on the updated values and start a transition animation. For example, if we hide the fab view, you'll see it fading away instead of immediately disappearing. Behind the scene, the framework sees that the visibility of fab changes and creates a fade transition. We can implement our previous animation by just setting the end values for each view, and it knows to create a change bounds transition. Whether to use this simplified method or explicitly create scenes depends on your actual use case. In general, it's suitable for animating views with dynamic target states and where the animation needs to start immediately. It is worth mentioning that, unlike creating scenes from layouts, this method reuses the views in the hierarchy instead of recreating them. So in this, you don't need to worry about rebinding or repopulating the views in the enter action. This can be quite handy. In the examples so far, we create our transition objects in Java code. Is it possible to do so in XML and use Android's powerful resource system to load the transitions? You bet. Just as property animations, you can define transitions declaratively in XML. You can then inflate the transition using Transition Inflator. Compared to Java code, transitions in the XML format are often a little easier to read and maintain, especially for complex transitions with nested transition sets. Also, it's easier to reuse transitions in XML because they are available globally.